Hi everybody, this is V. Kannaki, Associate Professor of EC Department in R.M.K. College of Engineering and Technology. In my last presentation, I have given an introduction about industrial safety and the necessity of studying industrial safety by electronics and engineering students. So now let us go into the first unit. So the first unit here, the contents of the first unit is evaluation of modern safety concepts, fire prevention, mechanical hazards, boilers and pressure vessels, electrical exposure. So coming to industrial safety. So when we start with the first unit of industrial safety, just we will recall the definition for industrial safety. Industrial safety is primarily a management activity which is concerned with management of events for the protection of employees by minimizing hazards. So in simple we can say industrial safety can be made by reducing, controlling and eliminating hazards from the industries or industrial units. So when we look into the classification of industrial hazards, the foremost one is chemical hazards, followed by mechanical hazards, physical hazards, electrical hazards, fire hazards. So let us see about mechanical hazards. We have already seen in the last presentation that a mechanical hazard is always related with a mission. So a mechanical hazard is any hazard involving a mission or process. So if you see the types of mechanical hazards, we can classify the types of mechanical hazards as friction, impact, shearing, high pressure injection, drawing in, entanglement, cutting, crushing and stabbing. Yes, so along with the types of hazards, the types of hazards we can again classify the mechanical hazards as shear point. So as we already said about mechanical hazards, as already we said about mechanical hazards are associated with power driven missions, whether automated or manually operated. So in an industry, people interact with machines that are designed to drill, cut, shear, punch, etc. So if appropriate safeguards are not in place, or if workers fail to follow safety precautions, machines can cause major human injuries. So the more common sources of mechanical hazards are unguarded shafting, shaft hinges, belt drives, gear trains, projections on rotating parts, chain and sprocket drives, any exposed component parts of machine or power driven equipment which rotate rapidly or have considerable power and may catch the worker, tangling him or in the machine before he or she can get free. Okay, so coming to shear point. Yes, so to understand what shearing is, just you think of a paper cutter. It shears the paper. So power driven shears for severing paper, metal, plastic, elastomers and composite materials are widely used in manufacturing. So in times past, such machines often amputated fingers and hands. So these tragedies typically occurred when operators reached under the shearing blade to make an adjustment or placed materials there and activated the blade before fully removing the ant. So that is shear point assault. And crush point. So when you say crushing, so injuries from crushing can be particularly debilitating, painful and difficult to heal. They occur when a part of the body is caught between two hot surfaces that progressively move together, thereby crushing anything between them. So, crushing assaults can be divided into two categories: squeeze point and run-in point. Next, pull-in point. So, pull-in point again, see all these assaults we can see with an example. Yes, shear point, crush point, pull-in point, burn point, drop point, freewheeling parts, stored energy, thrown objects. So all these hazards, so we can see what happens when these hazards are faced by an worker. Okay, so let us see with an example, just a video clipping. Let us see now.
Shear point. A shear point occurs where the edges of two machine parts move across or close enough to each other to cut a relatively soft material. A hedge trimmer is a good example of equipment with a shear point.
Next, crush point.
Crush point. A crush point is formed when two objects are moving toward each other, or when one object is moving toward a stationary object and the gap between the two is decreasing. A common example of a crush point is the point where an implement is attached to a tractor's drawbar.
Next, pull-in point.
Pull-in point. A pull-in point occurs most often where crops are fed into harvesting machinery. Pull-in points can be formed by moving components. To avoid being pulled into a machine, turn off the engine and disengage the PTO before doing any repairs or adjustments.
Burn point.
Burn point. Doing machine inspection, servicing, and maintenance are the most common types of activities that may result in exposure to a burn point hazard. To avoid being burned, do not immediately touch the engine or machine parts you are inspecting. Place your hand near the surface of the part to determine if heating has occurred. Wear leather gloves to protect your hands against hot engine parts.
Wrap point.
Wrap point. Any type of rotating machine component can be considered a wrap point. The rotating components are often shafts, such as the power takeoff or PTO. People can get caught by loose clothing or long hair. PTO shafts turn extremely fast and you can get caught faster than you can react. Wear snug-fitting clothes and tie up long hair. Keep the guards and shields of rotating parts in place. Wrap point.
Freewheeling parts.
Freewheeling parts. When parts of a machine continue to move after the power to the machine has been turned off, they are called freewheeling parts. To avoid injury from freewheeling parts, stop the tractor engine, disengage the PTO, and wait for the machine to stop completely before doing repairs or adjustments.
So, we have seen some examples of the mechanical assaults. Okay, So other than this, there are many mechanical hazards. Okay, coming to know about mechanical hazards. So mechanical hazards are those associated with power driven machines, whether automated or manually operated. So in an industry, people interact with machines that are designed to drill, cut, shear, punch, etc. So if appropriate safeguards are not in place, or if workers fail to follow safety precautions, machines can cause major human injuries. So all machines can cause damage to the property, and machines can also harm the environment. Okay, so we need to safeguard the workers, that is operators, from mechanical hazards. Okay, so safeguarding, let us see what is safeguarding now. So safeguarding is mission safeguarding. Mission safeguarding is to minimize the risk of accidents of mission operator who is in contact with the mission. The contact can be either a direct contact with moving part, or contact with chips, chemical and hot metal splashes, and circular saw kickbacks. And it can be caused by the direct result of a mission malfunction also. Types of guards. So when you say about safeguards, yes, so your safeguards, again you can classify the safeguards as fixed guards, interlocked guards, and adjustable guards. Fixed guards. Fixed guards, so it provides a permanent barrier between the workers and the point of operation. So they offer the following advantages. That means they are suitable for many specific applications, and for example, the safeguards can be constructed in plant and require little maintenance and are suitable for high production, then repetitive operations. So some of the disadvantages include that they sometimes limit visibility and often limited to specific operations alone, and sometimes inhibit normal cleaning and maintenance. Next, coming to interlocked guards. Interlocked guards shut down the machine when the guard is not securely in place or is disengaged. So the main advantage of this type of guard is that it allows safe access to the machine for removing jams or conducting routine maintenance without the need for taking off the guard. So there are also some limitations in the interlocked safeguard. See, these type of safeguards require careful adjustment and maintenance, and in some cases it can be easily disengaged. Coming to adjustable guards. Adjustable guards provide a barrier against a variety of different hazards associated with different production operations. So they have the advantage of flexibility. However, they do not provide as dependable a barrier as other guards do, and they require frequent maintenance and careful adjustment. Some guards in this category are self-adjusting too. Safeguard requirements. When we see about the requirements of safeguards, see, the first one is be secure and durable. Be secure and durable. Safeguards, these safeguards should be attached so that they are secure. That means workers cannot render them ineffective by tampering with or disabling them. So this is critical because removing safeguards in an attempt to speed production is a common practice. So safeguards must also be durable enough to withstand the rigors of the workplace, and worn out safeguards won't protect workers properly. Next, protect against falling objects. That is, objects falling into moving machine mechanisms increase the risk of accidents, property damage and injury. It should be prevented. So, when you say about this, okay, objects that fall on a moving part can be quickly hurried out, creating a dangerous projectiles. Therefore, safeguards must do more than just prevent human contact. They must also shield the moving parts of machines from falling objects. Then create no interference. Safeguards can interfere with the progress of work if they are not properly designed. So, worker may be disabled it due to work deadline. Safeguards can such safeguards are likely to be disregarded or disabled by workers feeling the pressure of protection. Then allow safe maintenance. Safeguards should be designed to allow the more frequently performed maintenance task. Then general precautions. So general precautions, the precautionary measures to use a safeguard to protect the workers from the mechanical hazards. So operators should be trained and supervised to ensure that they dress properly for the job, and shortcuts that violate safety principles and practices should be avoided. Other employees who work around missions but do not operate them should be made aware of the emergency procedures. And dear friends, thank you for listening to the mechanical hazards and its concept. We will meet again with a new topic. Bye.